Hello everyone, and welcome to this new video tutorial for Maverick Render. In this video we will present major improvements to the Round Edges map in Maverick Studio and Maverick Indie. The Round Edges map allows to artificially add fillets to hard edges and give them round appearance. Let's take a look at an example and open a scene. This text object is a simple font extrusion and exhibit hard edges. We will take a snapshot of the current render from the AB tab to later compare with the Round Edges version. Don't forget to mark the image you want to compare as A or B before enabling the comparator tool. To apply the Maverick Round Edges, select the object to display its material in the attribute editor. In the special rollout, new buttons are available to add and delete the Round Edges feature. Click on the Add Round Edges button. The bump input now displays as connected. Indeed, the Round Edges map is working on the bump channel. Click on the bump input to go to the Round Edges settings. The parameters are few and very straightforward. The radius controls the roundness amount. If we increase this value to 5, the effect is much stronger and more visible. Enabling the AB comparator now lets us compare and appreciate the difference Round Edges makes. Let's take a look at another example. This mechanical part is typical of what you can expect from CAD files, where many edges were not rounded to keep the model complexity manageable. Rounding all the edges with geometry would be impractical, raising the number of triangles considerably and increasing the chances of failures and holes. Apply a metallic material from the library to better see the edges and how they catch light. We will let the render clean a little and take a snapshot for later comparison. Now we can go to the material parameters, and add a Round Edges map. The model hard edges are now all nicely rounded. Let's compare both render. Don't forget to mark the image you want to compare as A or B before enabling the comparator tool. The difference it makes in the model realism is quite stunning. The Round Edges map is also smart, leaving actual geometry roundings untouched. Let's look at yet another example. This ring model features many hard edges that would look unnatural without rounding. Let's apply a precious metal material to this ring model. For example, this matte white gold. We will capture a snapshot of the scene before Round Edges again and mark it as the A render. The metal material makes it evident that the model looks quite flat and unrealistic. Again, go to the material settings and add a Round Edges map from the special rollout. The default radius of 1 mm works well for many standard sizes. Let's compare before and after again. The difference is striking, with perfectly blending artificial roundings everywhere it's needed, automatically. We will look at another example, a fidget spinner model. This model is very basic, with only the rough extruded shape and no rounding whatsoever. In such model, rounding should be quite significant with a rather large radius. Round Edges often fails to capture large radiuses without looking unnatural or showing artifacts. But not with Maverick Round Edges, as you will see in a moment. Let's dress this object a little, by applying materials. A clean metal for the bearings. and a painted metal for the body. For the sake of it, let's also add a material to the floor such as this blue polished plastic. Our materials now applied, let's go ahead and add them a round edge map. But first again, we will take a snapshot for later comparison. Apply the round edges to the metal bearing. The bearings are very small, and here the default radius is too large. Go the round edges settings and lower the radius, for example to 0.4 mm. As you can see, despite the material applies to the bearings spheres as well, they are untouched. We will do the same for the red material as well. Notice again how this radically changes and improves the render. We will increase the radius to further round the edges, to 1.6 mm for example. If we compare now, the difference is again striking. Without round edges, the render looks flat, uninteresting and unrealistic. The round edges allows the model to exhibit a much more realistic render. Let's load yet another example. This scene is made of several objects either touching or intersecting together. Here we have a box, here some cylinders and some rectangles. These objects are independent, but touching or intersecting. We will apply the same material to all of them. Select all the objects and drag and drop a material on the selection. As you can see, all the edges are hard, without any kind of rounding. Select the material, and from the special rollout add a new round edges map. All the edges are now rounded, including the edges where different objects touch. Go to the round edges parameters. The samples control the rounding quality. Increasing the number of samples will produce finer, more accurate results at the expense of a slightly longer render time. Reducing the samples too low below the default value renders faster but produces poorer rounding. As seen before, the radius controls the rounding size in millimeters. The scale parameter simply multiplies the radius, and allows to scale it down. The difference with the radius is that this parameter can be mapped to vary the rounding and create damaged edges, for example. The include parameter allows to select how the round edges map affect multiple objects or materials. In this scene, all the objects have the same material, so the round edges map works on every edge of every object using the same material. If you change the include parameter to same object, the round edges now ignores where the objects are touching or intersecting. It only applies to each object independently. Changes the include back to same material, and now objects are blending into each other. This produces a result similar to merging objects using a Boolean operation and rounding the intersecting edges. It is a very powerful and easy way to greatly increase mechanical pieces' realism with virtually no cost or extra modeling work. Now we will see how using a scale map can create very interesting edge wear and damage. Click on the scale map input and select a noise map, for example. Lower the size to a meaningful value for the scene scale, such as 0.05, which is 5 cm. Then, if needed, adjust the low and high sliders to increase the noise map contrast. The rounded edges regularity now appears broken up. By adjusting the parameters to more sensible values, you can achieve very interesting effects to break the usual perfection most renders suffer from. Finally, we will see how we can mix the round edges map with another bump map. Click the Delete Round Edges button. From the Shading library and the Patterns Maps subcategory, drag and drop a pattern to the Materials bump input. Click on the Materials bump input. The drag and drop operation automatically added a Maverick bump node. Click the input slot and there is the pattern texture map. Here you can change the tiling, or repetition. Increase both U and V repetition values to 25 for example. Our object now shows a bump pattern but no round edges anymore. From the Materials Special Rollout, click the Add Round Edges button again. Adding the round edges map on top of an existing bump map automatically creates a Maverick bump blend node. The bump blend node allows you to mix up to 4 different bump and normal maps together to increase the bump complexity and details without having to create a new texture on your hard drive. Each bump layer has a weight slider, allowing to control the intensity. Note that the round edges map is set as the base bump map, as its effect must be preserved fully. You can still control the round edges map parameters from here. That's all for this tutorial. We hope you will enjoy this new feature and put it to great use. Thank you for watching this video. Have fun rendering with Maverick.